Hello again, this is Dave with OC Astronomy. We've just walked through the Celestron Edge 1100 HD, and we've talked about putting it together for the first time. Some things to know, important things to know. So one interesting little addition to the family that we got is this. This is the Celestron Focal Reducer 0.7. And its job is, this is an f10 scope. So if you want to be at f7 to get a little bit wider angle on things and be able to see some nebulas, be able to make a little bit wider of a view, then you want to have a focal reducer. This focal reducer is no joke. It is not the original. I've had the Celestron 6.3 reducer. It is not in the same league. This is 5 elements, I think, and it's designed to work with the Edge optics to still give a flat image, especially with a camera. It's designed to work with your digital SLR camera, and that will widen your view and put as much as you can of a view onto your chip. The price tag is stiff. It is $600. No joke, $600. But I think it's well worth the cost. And you'll notice I have a little friend on top here. This is the Moonlite Crayford Focuser, and it's designed to have a 2-inch eyepiece put into it, or in my case, there's an adapter with the T-threads that I'm going to use for my camera. So the way that this is going to be set up, you have your focal reducer, and then you have the barrel of your focuser, and there's an extender right here. I'll talk about that in a second. And then your ring, and the ring that I'm going to use with the camera has a T-thread on it, so it'll all be screwed together from the rear cell all the way through the focal reducer, the focuser itself, the off-axis guider, the filter wheel, and the camera. They're all screwed together so that you won't have any flexure going on. You won't have any miscollimation because your adjustment screws are pushing any element off center line. So all these should be lined up on center line if everything goes according to plan. And this spacer here acts in concert with the length of the focuser and the focal reducer itself to put your image at exactly a length specified in the literature. You've got to get it right on line for the Edge HD optics to work, to give you a nice flat image and pinpoint stars. You have to get that distance to the camera sensor from the threads on the back through all the other elements to the camera sensor. It has to be, I believe, 146 millimeters, something like that. It adds up fast. And so if you're putting a focal reducer and a nice electric focuser, because we've got a stepper motor, another nice bit from Moonlite there. You got your stepper motor, you've got your filter wheel, off-axis guider, and then the actual camera back focus to consider. You've got to add up all of those elements to get you at the right distance. That's the only place in the setup where your images are going to be pinpoint stars. Anywhere closer, anywhere further away, then at the outside edges it starts first, and then you get teardrops, 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 teardrops until you get to the middle. It won't be that bad unless you're just way, way, way off. But you set your focus with your with the knob on the telescope, and then you set the focus of the focuser halfway, and then you use the stepper motor to adjust for cold or heat to get your focus dead on. You also are maybe adjusting depending what kind of filters that you have, if they're exactly parfocal or not. You may want to shift those if they have a little bit of difference. You may need to adjust focus between filters. So that's why you want to have a zero shift focuser on the back. Now, why zero shift? Well, old-time users of SCTs are familiar with, when you turn the focus knob, it either pushes or lets go on the actual mirror cell. That's how it's achieving focus. So if you're pushing the mirror cell and then it starts to scoot up, and then you're releasing the mirror cell and it starts to scoot down, every time that you push on the cell, you're gonna get image shift. And if you have a really small sensor, then that could be quite significant. You could actually throw yourself off target and your alignment's not gonna be getting any good anymore. So you need to have some means of focusing. This is what I wanted to do with the stepper motor and this focuser. It's a very controllable option. I can do it from a PC or laptop hooked into a USB port. So that's what we're going to do for focusing. Now that's going to be here's the question that I have. I am already at I'm already at the end. I don't have very much more to go, and that focal reducer and the focuser itself and the camera body are going to be heavy. So I guess I'm going to have to get a counterweight that attaches up here to offset that weight. That's the only thing I can think of. So I've got to get that ordered in the mail before I can even attempt to use it for photographic use. What I am going to do, though, I'm going to set the thing up in the dome at first for visual use anyway, because my first job is going to be polar alignment. I'm going to lock down the polar alignment and get it dead on as much as I can, and use those adjustments and try to do the 2 or 3 star alignment, and then do the all-star polar alignment, and then go back and do it a couple more times until I'm happy. But then I know whenever I put the camera on, it may shift a little bit from there, so I'll have to look and see. But at least that'll be a whole lot closer, and it'll guarantee that whenever I do put the camera on, I'm going to at least have the star that I'm looking for whenever I do the polar alignment with the camera on it, the all-star polar alignment. I will at least get the dot of the star on the sensor frame. That's all I really care to do. I don't care, if it's off by half the frame or not. That's fine if I have to redo my alignment, because the weight's going to change whenever I put that on there, and I don't know how that's going to affect any small degree of polar alignment. You guys know the routine. Any small little change and it throws it off. And if you're after good photos, like the Hubble images in the background there, good luck with that. But if you're after good photos, any small little change, you gotta correct for it. So here's our neat little focal reducer. It is so heavy. I wish you could feel it through the camera. It is heavy. There's 5 glass elements in there that are 2 inches in diameter or more, and plus the metal housing. It is a metal housing, not plastic, and it is all milled very nicely. But when you add the focuser body to it and you add the motor on the side of it, I haven't weighed it, but it's got to be pretty substantial. So we throw the weight of that on there, and I'm sure it's going to mess with my polar alignment. Anyway, that is how we're going to use it photographically, and a quick run through of what we're planning on doing. Hope that you enjoy. It'll be fun. We'll see how our first images go.